going to start talking about motion now in one dimension. And we're going to start out talking about distance and displacement, which we introduced a little bit ago. For both of them, we use a variable delta x. Okay, they're both about change in position. Okay, but they're different in that distance is a scalar. You have to remember what scalar means. Scalar means there's no direction involved, and the distance is just how far you've traveled total. And displacement is the vector, and the definition of that is how your position relative to your starting point. And then speed and velocity. This is new. We use these words kind of interchangeably in the English language. They both mean kind of how fast you're going. All right, so let's make a note of that. V is how fast you're going. Okay. Speed is the scalar. So it doesn't have direction involved. And velocity is the vector. Okay? So if I look at my speedometer, I'm traveling on the highway and it says I'm going 50 miles an hour, that's my speed. For velocity, I would also have to tell the direction. So if I was going 50 miles an hour north, that would be my velocity, 50 miles an hour north. My speed would just be the 50 miles per hour. Now, we're going to start out with constant or average speed problems. We're going to use the equation V is delta x over delta t. We're going to put a little line over it. Okay, the line means average. So we're going to write down that this is for our average velocity or speed. Okay, be careful when using this equation. It is only for average speed, not the speed at any one moment. I'll talk about that in a second. When something's accelerating, you don't want to use this equation. Most likely. Now, V is average velocity if you use displacement for the delta x. V is speed if you use distance. So we use this same equation and we use the same variable for both velocity and speed. You just have to be a little bit careful. When you want to find velocity, you have to use displacement. When you want to find speed, you just use distance. So here's an example. A ball rolls 1.6 meters down a ramp in 0.4 seconds. What is the average speed of the ball? So this is a distance. Our letter for distance is delta x. This is a time, so we call that delta t. And then I want to find speed. Speed is v, average speed. So we're going to do v is delta x over delta t. It's 1.6 meters over 0.4 seconds, and that's going to give me 4 meters per second. That's going to be our unit for velocity or speed, is going to be meters per second. Now, in order to find the velocity, I would need to know direction. So you need direction. Now, that doesn't really tell us very much about the motion of the ball. We know its average speed was 4, but we don't know what its speed was at any moment along the path. That's why we can only use this equation to find average speed. If it said what's the speed at the end of rolling down the ramp, we don't know that. Our next example is here. Okay. In this one, we have a car traveling 200 miles north in 5 hours. It stops for 30 minutes. Then it goes east for 300 miles in 6 hours. And part A is just asking for the distance traveled. So for distance, I don't worry about direction. It's just the total traveled. It's the scalar. Direction isn't important. So it's just going to be 200 miles plus, when it was stopped, 0 miles, and then 300 miles. So that's going to give me a total of 500 miles for the distance traveled. And I can label that as delta x, because delta x can stand for distance. For part B, it asks for the displacement. Displacement is where you are relative to your starting point. So for this, we have a little bit more work to do. Okay, he goes 200 miles north. Okay, stops for 30 minutes and then goes 300 miles east. And our displacement, which we still can call delta x, is going to be that side of the triangle now. Since we're at right angles, we can use Pythagorean. So delta x squared equals 300 squared plus 200 squared. So if we do our work right, we're going to end up with a delta x 361 miles. Now, to be specific, we also should probably find an angle. I like to use like east and west as my reference angle, so I'm going to try to find that angle there. Okay, if I think about that angle, it's the same as this angle. All right, and my 200 is my opposite side, my 300 is my adjacent side. And so I would use tan for opposite over adjacent. So tan theta is equal to opposite. So 200 over my adjacent, which is 300. And that's going to give me theta equal 33.7 degrees north of east. So that's my displacement. Third part, average speed. So for part C, we're going to find average speed. For average speed, we're going to use this equation. It's just distance divided by time. I'm going to ask you this probably from time to time. What's the easiest way to measure someone's speed? If they were running down the hall, we'd measure their distance and divide it by how long it took for them to do it. So speed is distance divided by time. So it's going to be 500 miles divided by. Now the time it took, to go back up to this problem, we have 5 hours, we have 6 hours, and we have 30 minutes. That's part of the trip too, so we're going to count that in. So it's going to be 11.5 hours. So 11.5 hours. I add the 5 and the 6 and the half hour, and I get that. And then when I divide, I get an average speed of 43.5 miles per hour. And then the last thing I want to find is the average velocity. We use the words velocity and speed sort of interchangeably, but they're actually different. We use the same equation, but for average velocity, I'm going to use displacement over the time. So the displacement we just found over here was 361 miles divided by the time it took was still the 11.5 hours, and we get a value of 31.4 miles per hour. And if we want to be real precise, we should have a direction as well, okay? And the direction is going to just be the same. It's going to be at 33.7 degrees north of